Right now, you're watching famous German engine builder Michael Mittler hand-assemble this powerful and expensive AMG inline-4 engine. Mercedes employs several dozen specialized technicians like Michael, and each of them assembles several engines per week. In 1 year, a single technician can assemble up to 200 engines. So this is the process of manufacturing the Mercedes AMG M139 engine, a 2.0-liter engine with 421 horsepower. These M139 engines are installed in models like the Mercedes A45, CLA45, or C43. Unlike AMG V8 engines, which are produced in several thousand units per year, the M139 engines are made in much smaller numbers annually. Unlike mass-produced engines, these inline-4 engines are built at a single workstation. The engine stays in one place while the worker brings all the tools and parts to it. The Mercedes AMG M139 engine is a true masterpiece of modern performance engineering. With its 2.0-liter turbocharged 4-cylinder design, it currently holds the title of the most powerful production engine of its kind in the world, delivering astonishing power and precision for a compact sports engine. What you are watching right now is the core idea behind the production of these powerful engines, called one man, one engine. This philosophy means that each engine is assembled from start to finish by a single AMG technician, whose name is proudly displayed on a plaque atop the engine. Each of these engines is built at the engine plant in Affalterbach, Germany. The plant produces some of the most powerful engines, including V8s, V6s, and the legendary M139 inline-4. These engines are built exclusively for high-performance models. Despite being hand-built, the plant uses modern technology to support assembly, precision measurement tools, engine testing rigs, and special lifting systems. The training of this muscular worker in the black shirt is intensive, often taking years to master the high standards of AMG. The facility is designed according to Industry 4.0 principles, featuring smart manufacturing, digital support systems, and modular workstations. Some engines from a Affalterbach factory are so rare that only a few thousand are made per year, especially V8s. Meanwhile, the M139 inline-4, while more common, is still a hand-built high-performance marvel. Precision tools and sensors guarantee that all torque settings are exact, while each engine undergoes thorough testing on dynamometers. This process includes leak checks, monitoring of oil pressure, and full performance runs to ensure the engine meets the highest standards before leaving the facility. Right now, you're watching the precise assembly of the crankshaft inside the engine. Forged from high-strength steel, this crankshaft is built to withstand extreme RPMs. Thanks to careful calibration and hardening, it can handle engine speeds of over 7,200 RPM in the S version. Its shape is optimized to reduce rotational losses and vibrations, which is especially important for a high-performance 4-cylinder engine. The turbocharger and exhaust manifold are located at the rear of the engine, near the firewall, while the intake is at the front, opposite to a conventional layout. This design helps improve airflow and cooling. The crankshaft is made of forged steel for low inertia. The pistons are forged aluminum for strength, and the connecting rods are forged to make a strong but lightweight engine. The twin-scroll turbocharger has roller bearings to reduce friction. an electronically controlled wastegate, and can reach a maximum turbine speed of about 169,000 RPM. The engine has two separate cooling circuits for the head and a crankcase, an electric water pump that cools the block independently of engine speed, and a liquid-to-air charge air cooler for high thermal efficiency. So the one-man, one-engine principle means that each AMG engine is built start to finish by a single highly trained technician. That technician is personally responsible for the full assembly of the engine, not just a single task on a conveyor line. The cylinder walls are coated with nanoslide, which reduces friction, improves durability, and helps manage heat. With a specific output of 210 horsepower per liter, this engine ranks among the highest in automotive history for production cars. The tools include digitally monitored, torque-controlled wrenches to ensure every part is installed perfectly. Each technician is personally responsible for the quality of their engine, creating a strong sense of pride and accountability that helps deliver higher reliability and performance. After the assembly of each M139 engine, a metal plaque is attached to the top of the engine cover, proudly displaying the name and signature of the technician who built it. This is more than just a badge. It is a symbol of the craftsmanship, precision, and care that goes into every engine. Each plaque represents the human skill behind the technology, highlighting the tradition of hand-built performance engines. It is a visible reminder that behind the extreme power and advanced engineering of the M139, there is a personal touch, pride, and accountability in every detail. Human craftsmanship ensures personalized attention to every engine. Quality control reduces errors and maintains high consistency. Brand heritage reinforces AMG's racing and performance roots. Customer connection makes each engine feel unique and special. Right now, you're watching how dual overhead camshafts are assembled. The camshafts are made of hardened steel and have precise shapes to control the valves at very high RPM. Both the intake and exhaust camshafts use Camtronic variable timing, which changes how the valves open and close. This helps the engine have more torque at low speeds, better fuel efficiency, and smoother power delivery. It also reduces turbo lag, which is important for a powerful small engine like the M139. Throughout the video, you can see that AGV vehicles are often used to transport the engines. These vehicles are programmed to carry engines across the factory floor. Automated guided vehicles help reduce the need for manual handling, ensuring that heavy engines are moved precisely without risk of damage. They follow predetermined paths, coordinate with workers and equipment, and keep the assembly line running smoothly. Even though each engine is hand-built by a single technician, AGVs make the logistics behind the production seamless, allowing technicians to focus entirely on assembly. This combination of human craftsmanship and smart automation is a key part of AMG's approach to high-performance engine production. Pride and accountability motivate technicians to deliver perfection. Engines with this philosophy include the 2.0-liter inline-4, 4-liter V8 biturbo, and V12 biturbo used in AMG and Maybach models. The one-man, one-engine approach is a core part of AMG's heritage, blending advanced manufacturing with skilled craftsmanship. The average time is 3 to 4 hours, covering component preparation, full manual assembly, torque verification, digital logging of build steps, and leak testing with inspection. Technicians often build only 1 or 2 engines per day depending on model. Even though it takes hours to build one engine, AMG could automate it, but they intentionally don't. Now the technician, Michael, personally tests the engine he just assembled. This factory produces 140 of these engines daily. Affalterbach is where AMG transformed from a 2-man tuning shop in 1967 to a world-famous performance division. The AMG engine plant in Affalterbach employs around 300 people, including engine builders, support staff, and management. Of that, approximately 120 engine builders are fully qualified to sign their own engines, equipped with decades of mechatronics training. There are roughly 60 standard engine builders, each responsible for normal AMG badged engines, silver plaques. An elite group of about 14 to 16 Black Series builders, black plaques, are certified to assemble high-performance, limited-run engines. After completion, these engines are transported to storage and sent to the main assembly line at the designated time, where they are combined with the chassis. The sign plaque isn't just symbolic. It represents individual accountability, highest quality standards, and mastery of craft. Right now, you are watching the sub-assembly of the entire dashboard of the 6th generation Mercedes-Benz S-Class. This generation was produced from June 2013 to September 2020 and carries the internal designation W222. During this period, more than 540,000 of these global flagship luxury sedans were produced. The largest single market for the W222 was China, which accounted for about 1/3 of all S-Class sales during this generation, followed by the US and Germany. The core assembly and engineering hub for the W222 was the Sindelfingen plant in Germany. Right now, you are watching how workers in 2015 worked on the underside of the car, which was rotated onto its side using a massive manipulator arm. During peak production periods, about 250 vehicles rolled off the assembly lines each day, and the facility employed tens of thousands of workers focused on premium and luxury vehicles. Each car effectively had a digital blueprint on the assembly line, allowing hundreds of possible configurations to be assembled without mistakes. Many areas, especially interior trim, wood inlays, and leather stitching, were hand-finished by skilled technicians. Right now, you're watching a production process called the marriage. The marriage is the process where the car's major assemblies, like the car body and the drivetrain, are brought together and joined. It's called marriage because two main components are united to become a complete vehicle structure. Panels, doors, and hood gaps were meticulously measured. Mercedes aimed for sub-millimeter accuracy, making the W222 feel perfectly built when you opened a door. Some W222 with this advanced suspension system were calibrated individually on the production line. Each car's sensors and hydraulics were tuned for optimal ride. As you can see right now, the front grille of this 6th generation S-Class was assembled with the help of a robotic arm. While hand craftsmanship was crucial, robots handled painting, welding, and heavy assembly tasks, ensuring consistency across thousands of vehicles. This S-Class was offered with a wide range of engines, including hybrid and plug-in hybrid options, as well as petrol and diesel engines ranging from 4-cylinder units for select markets to powerful V8s and V12s, including AMG performance variants. Right now, you are watching how doors were assembled using a manipulator arm. This allowed Mercedes factory workers to guide the doors into position without having to hold their full weight. Doors are installed this way, even today. The sixth generation was one of the best-selling luxury sedans in the world during its lifetime. Strong demand in China helped the model achieve impressive production figures and maintain the S-Class's dominance in the luxury market. With its extensive use of leather, wood, and premium metals, the W222 set the benchmark for quality, comfort, and technological integration. Features like rear seat entertainment, executive seating packages, and night vision assist turned it into more of an owner's limousine than just a car. The 2017 facelift refreshed the styling and introduced improved efficiency and technology features, representing a mid-cycle high point for the model before the transition to the newer W223 generation. For this generation of the S-Class, traditional luxury colors were the most popular, particularly silver and black, which continue to be the most commonly seen on the road. This is how the Mercedes-AMG 63 V8 engine is made. Every AMG V8 is meticulously hand-assembled from start to finish by a single master engine builder, ensuring exceptional precision, craftsmanship, and performance in every engine. Instead of moving along an assembly line like mass-produced engines, the V8 is built in one location with all tools and components brought to the engine. Compared to regular Mercedes engines, AMG 63 V8 production is very limited, with each builder producing only a few engines per day and some assembling fewer than 200 engines per year. This low output is why V8s are increasingly rare and expensive. Manufactured at Affalterbach plant in Germany, these engines are assembled in a climate-controlled clean hall with critical tolerances measured to micron-level precision. Each part is measured multiple times during assembly, not just pre-assembly. Parts are often select fit rather than interchangeable. Two identical engines may use slightly different bearing shells or piston grades to achieve perfect balance. Modern Mercedes 63 engines use a closed-deck aluminum block that significantly strengthens the cylinder walls and allows the engine to withstand extremely high turbocharged cylinder pressures. This design also offers exceptional tuning headroom with outputs well beyond 700 horsepower achievable on stock internals. Every Mercedes AMG is built with a forged steel crankshaft, forged aluminum pistons, and forged connecting rods, providing the strength and durability required to handle significantly increased power levels. Many high-performance engines in the same price class still use cast components. Forging allows higher RPM, higher boost, and greater durability under thermal stress. The crankshaft, pistons, and connecting rods are precisely balanced as a matched set, ensuring optimal smoothness and durability. Even the flywheel and harmonic damper are individually selected and verified specifically for each engine. Beyond mechanical balance, the engine is also thermally balanced, taking into account material expansion at full operating temperatures. This level of precision is far more common in race-built engines than in conventional street applications. The cylinder heads are CNC, machined for exceptional precision, while critical areas such as the valve seats and intake and exhaust ports are carefully hand-finished. Valve clearances are set manually, and the camshafts are installed and timed by hand to ensure exact specifications. AMG prioritizes absolute consistency and quality over assembly speed, even when this approach limits overall production volume. The AMG 63 V8 engine powers a wide range of high-performance Mercedes-AMG vehicles spanning sedans, coupes, sport utility vehicles, and grand tourers. It appears in flagship performance sedans such as the E-Class, CLS, and S-Class, along with their coupe counterparts. In the SUV lineup, the engine is featured in models like the GLE, GLS, and the iconic G-Class. It also serves as the heart of performance-focused vehicles, such as the AMG GT four-door coupe. Depending on the vehicle and its intended role, different versions of the 4-liter biturbo V8 are used to optimize performance, responsiveness, and character. Many AMG engine builders bring decades of experience to their work, often ranging from 10 to 30 years, having been trained directly by earlier generations of AMG master builders. These technicians frequently specialize exclusively in V8 engines, refining their skills over years of focused practice. At AMG, engine assembly is treated as a true craft rather than a routine job rotation, with an emphasis on deep expertise, accountability, and pride in every engine produced. This practice not only ensures meticulous craftsmanship and accountability, but also connects each engine to the individual who brought it to life, turning every power plant into a unique testament to skill and dedication. These builders form a highly specialized and closely knit team within AMG's Affalterbach production facility, representing a small but elite group dedicated exclusively to crafting the brand's most powerful engines with unmatched precision and care. Each AMG engine is the personal responsibility of a single builder who oversees it from the bare block all the way to completion. When the engine is finished, it receives a metal plaque engraved with the builder's name, a mark of pride and accountability. This signature is more than symbolic. The builder personally measures clearances, torques every bolt, and verifies all critical tolerances. Should an issue ever arise, AMG can trace the engine directly back to the individual who assembled it, ensuring full transparency and maintaining the highest standards of craftsmanship. This is how the 4-cylinder engine is crafted at the heart of powertrain production inside the Untertürkheim plant. The plant handled machining and assembly of major engine components such as crankcases, cylinder heads, crankshafts, and connecting rods for these engines as part of the integrated Mercedes-Benz powertrain production system in Germany. Untertürkheim has a long tradition of 4-cylinder engine production, dating back decades, including major petrol and diesel units that powered many Mercedes models. Early post-war 4-cylinder engines were built here, and by the 1990s, large-volume 4-valve 4-cylinder units, like the M111 engines, were produced on site for a range of vehicles. In the late 2000s, new generation 4-cylinder diesel engines went into series production at Untertürkheim, with significant investment in machining and assembly facilities for crankcases, cylinder heads, and core components. These factory workers in Mercedes t-shirts are working on crankshafts, pistons, and camshafts, which are meticulously installed. Robots handle the precise insertion of pistons and bearings, while human technicians oversee delicate tasks like timing chain installation and fine lubrication. Robotic arms and automated torquey tools ensure that all bolts and fasteners meet exact specifications every time. Today, Untertürkheim remains an important center of engine and powertrain production, but the site is also evolving with continuing production of electric drive units and future propulsion technologies as Mercedes transitions toward electrification. Cylinder heads with their intricate valve trains are assembled and tested separately before mounting. Camshafts, valves, and timing components are calibrated and aligned using sensors and digital measurement systems. Once installed on the engine block, the cylinder heads undergo tightening and leak testing to ensure perfection. Last year, the Mercedes-Benz Untertürkheim plant employed approximately 16,700 people. The engine is then completed with ancillaries, including turbochargers, if applicable, fuel injection systems, water pumps, and electronics. Each engine is bench tested under simulated conditions for power, efficiency, and durability, with advanced testing rigs capable of simulating thousands of kilometers of operation in just hours, detecting even the smallest irregularities. Right now, you're watching German master builder Janik Stahl meticulously hand-assemble this high-performance and highly valuable engine. He is one of the select few technicians entrusted with personally assembling AMG V8 engines, specifically the 4-liter twin-turbocharged V8 that powers some of Mercedes-AMG's most iconic vehicles, including the GT, the G-Class 63, and the S-Class 63. Every step he takes reflects years of training, experience, and dedication to precision craftsmanship. As part of AMG's renowned one-man, one-engine philosophy, Janik personally assembles each piston, carefully torques the cylinder heads, and installs the turbochargers himself. Every step of the process is performed with meticulous attention to detail, turning the assembly of this powerhouse engine into a true act of craftsmanship. He, along with a handful of other technicians, belongs to an elite cadre of highly skilled craftsmen chosen specifically to handcraft AMG's most legendary and high-performance engines, where precision, expertise, and dedication define every step of the build. At Mercedes-AMG, around 50 master engine builders are entrusted with the hand assembly of every AMG engine. Each builder personally signs their work with an engraved plaque, a tradition that embodies the brand's legendary one-man, one-engine philosophy. Most engine plaques are silver in color, representing the majority of high-performance V engines designed for both everyday driving and performance-focused models. Right now, you're watching him carefully install all 8 pistons into the engine. These V8s, including the 4.0-liter twin-turbo 63 series, use forged aluminum pistons engineered to handle extreme conditions. They withstand the high cylinder pressures of twin turbocharging, operate reliably at high RPMs, and endure intense thermal loads. Compared to standard cast pistons, the forged design offers superior strength and durability, enabling these engines to support both factory performance and extensive tuning without requiring internal upgrades. Every engine is rigorously validated for sustained high-speed autobahn runs, track use, extreme hot and cold temperatures, and long oil change intervals, a level of testing that explains why stock AMG engines tolerate aftermarket tuning so exceptionally well. Any engine built for regular AMG series production, like performance sedans, coupes, and SUVs that aren't special limited editions, will typically get a silver badge with the builder's signature. A select group of elite engine builders is tasked with assembling Black Series power plants, the most extreme track-focused variants produced. These specially chosen technicians are honored with black plaques at the top of the Wall of Fame in the Affalterbach workshop, marking their role in building engines that feature unique components and enhanced performance tuning. This crankshaft serves as the beating heart of the engine, with every stage of its manufacturing and finishing reflecting race-level engineering. Unlike conventional engines, these high-performance power plants never use cast crankshafts. Each one is fully forged for maximum strength and durability. Crafted from high-strength steel alloys, often microalloyed chromium molybdenum steel, the forging process aligns the metal's grain structure, significantly enhancing its resistance to fatigue and stress. The result is a component capable of withstanding extreme forces, high RPMs, and the rigorous demands of both everyday driving and track performance. This is essential for enduring high boost pressures, intense RPM loads, and sudden torque spikes. While the forging process is performed industrially, the finishing remains highly hands-on, with critical grinding and polishing carried out by skilled technicians using hand-guided machines. The crankshaft isn't balanced in isolation. Each one is dynamically balanced together with its matched set of pistons, connecting rods, das, and flywheel. Tiny counterweights are sometimes fine-tuned by hand, and in some engines, micro-drilled counterweights are used to achieve near-perfect rotational balance. The builder may use click-type torque wrenches for tactile feedback, or electronic torque wrenches for precise readings down to 1 Newton-meter. The engine builder personally torque keys all critical fasteners, including cylinder head bolts, main bearing caps, and connecting rod bolts. Even bolts of the same nominal size can require slightly different torque angles to compensate for variations in material expansion, bearing tolerances, or the flatness of the cylinder head. This hands-on approach ensures perfect sealing and even stress distribution throughout the engine, helping to prevent head gasket leaks, bearing failures, and uneven wear or warping caused by thermal stress. In these high-performance V8 engines, which experience extreme boost pressures and torque levels approaching 900 Newton-meters, improper bolt torquing could have catastrophic consequences, making meticulous hand assembly essential. Critical bolts undergo a multi-step torque process. They are first hand-threaded, then given a preliminary torque, followed by near-final torque using a precise wrench, and finally tightened to a measured angle to ensure perfectly even clamping pressure. This is especially important for cylinder head bolts, which seal the combustion chambers under extreme pressure. It is also critical for main bearing caps, which secure the crankshaft under high torque. Many owners of these high-performance V8s cherish their cars for the thrilling driving experience, distinctive exhaust note, and raw performance, even if they're not completely without quirks. Surveys of owners beyond enthusiast forums consistently reflect high satisfaction and strong praise for the car's performance. A highly engaging and characterful engine, though not entirely bulletproof. Many owners adored its personality and performance, but some issues emerged as the cars aged. Early models were particularly prone to cylinder head bolt failures, which could result in costly repairs. While oil consumption and occasional leaks are commonly noted by owners, sometimes necessitating more frequent top-ups or checks, the engine's drivability, soundtrack, and performance rarely disappoint. For many, the unique feel and character of the engine are irreplaceable. Some owners strongly caution about potential engine and transmission issues, particularly in high-mileage or hard-driven cars. Meanwhile, you're watching Janik Stahl affix the signature plaque bearing his name, marking the completion of his meticulous work. Only about 13 mechanics are appointed to this exclusive group, selected for their experience and qualifications, sometimes even by lot among equally capable candidates. Silver badges recognize expert engine builders who assemble high-performance engines, a rare skill in the automotive world. Black badges, in contrast, signify membership in an even more exclusive group entrusted with the most demanding, highest output engines produced by AMG. Whether silver or black, all badge-earning technicians complete extensive training at AMG's Affalterbach facility. A black badge goes beyond a visual distinction. It signifies that the builder has reached the highest tier of trust and expertise, responsible for engines featuring specialized components and enhanced performance targets. Janik Stahl personally oversees the complete assembly of each engine, handling every step himself, from installing the pistons and torquing the cylinder heads to completing the final build. Once the engine is finished, he affixes the signature plaque bearing his name, a mark of craftsmanship and personal accountability, onto every power plant he completes. It reinforces the idea of AMG as a performance brand with a human touch, distinct from fully automated engine production in the broader Mercedes-Benz group. As the brand shifts toward four-cylinder hybrids and electrification, the 63 Series high-displacement engine remains one of the last hand-built performance power plants, carrying forward a direct lineage from Mercedes motorsport engineering. Among SUVs, it is found in the high-performance GLE, GLS, and G models, while the GT and GTS four-door coupe also feature this engine. Different vehicles may use specific variants of the twin-turbo V configuration depending on the application. The nearly completed engine is now transferred to the testing department inside the German factory. Over more than 2 decades, the 63 Series V8 has continually evolved, transforming from a naturally aspirated unit into a highly efficient twin-turbocharged powerhouse. Once finished, the engine is tested and then forwarded to be installed in whichever AMG model it is destined for. This is the Mercedes-Benz factory near Moscow, Russia. The factory was built specifically for the local production of Mercedes vehicles in Russia. The facility was part of Mercedes-Benz's global production network, which includes more than 30 manufacturing locations worldwide. The first model manufactured there was the Mercedes-Benz E-Class sedan. A total of around 4,000 Mercedes E-Class vehicles were produced at this factory during its 3 years of operation. It was a full-cycle production facility, meaning it handled body welding, painting, and final assembly. The factory was built specifically for the local production of Mercedes vehicles in Russia. Mercedes-Benz invested over 300 million euros into the plant. Right now, you are watching the body in white manufacturing process. At this stage, the basic vehicle body is formed before painting. It was a full-cycle production facility, meaning it handled body welding, painting, and final assembly. This factory was Mercedes' attempt to create a mobile plant that could be quickly and easily set up anywhere in the world while maintaining the same production standards as their factories in Germany. This worker carried out the final quality inspection of the body in white. She mainly monitored the dimensions of the gaps between individual body panels. This factory was highly modern and flexible, using Industry 4.0 production technologies similar to other advanced plants. The production capacity was around 25,000 to 30,000 vehicles per year. In addition to the workers on the main assembly line, more than 1,000 employees worked at the facility. Right now, you can see the automated painting process using robotic painting arms. This process is very similar to that used in Mercedes-Benz factories in Germany. The process typically consisted of 4 to 5 layers. First, the body in white was treated with a pre-treatment and cathodic dip coating, which provided strong corrosion protection by fully sealing the metal surfaces. Next, a primer layer was applied to create a smooth surface and improve paint adhesion. This was followed by the base coat, which gave the vehicle its color. Finally, a clear coat was applied to protect the paint from UV radiation, weather, and mechanical damage, while also giving the car its characteristic gloss. It featured driverless transport systems to move car bodies between production stages. The factory used automated material delivery systems, human-robot cooperation areas, and solutions to improve ergonomics and efficiency on the assembly line. Even Mercedes built the plant to be closer to the large Russian market, where premium German brands, like Mercedes, had strong sales growth. In the decade before the plant's opening, Mercedes became one of the best-selling premium brands in Russia, more than doubling its sale. After Russia's 2022 invasion of Ukraine and the imposition of Western sanctions, Mercedes-Benz announced that it would halt exports to and local production in the country. In April 2023, Mercedes sold its Russian assets, including the Moscow region plant and local subsidiaries, to the Russian dealership group Avtodom. In its early years, the workforce combined local Russian employees with German engineers to transfer expertise, training the team in Mercedes quality standards, safety protocols, and lean manufacturing, just like in the German plants. Like German factories, the workforce was organized into multidisciplinary teams, combining skilled human craftsmanship with automated processes. Employee productivity and engagement were monitored carefully as Mercedes aimed for the same precision and quality as in Sindelfingen or Untertürkheim.